Maseno School, July-August mock 2024, Chemistry Paper 3. You are provided with solid A, 2 more hydrochloric acid solution B, 0.1 sodium hydroxide solution D. You are required to determine the enthalpy change for the reaction between solid A and 1 mole of hydrochloric acid. Procedure A. Using a bullet, place 20 centimeters cube of 2 molar hydrochloric acid solution B in a beaker. Add all solid A to the acid. Stir the mixture gently with a thermometer. Measure the temperature of the mixture after every half a minute and record the values in the table. Retain the mixture to be used in procedure 2. Hapo ndio unafaa kushika. Procedure 2 needs for you to use what you have retained. So retain the mixture, usimwage. So we are going to fill the table. Temperature should be given to 1 decimal place. Always remember that temperature is to 1 decimal place. So if you get 22, make sure you write 22.0. If you have 24, it is 24.0. So that now when you get 27.5, you can be able to write it that way. So temperature is always recorded to 1 decimal place. As you can see, I'm filling the table like that. The decimal point must be consistent throughout. So usifike mahali unaweka decimal point na kwingine uweki, inamaanisha you are going to lose a mark there. Because for you to get the complete marks for the table, you must have a consistent 1 decimal place for the temperature, and there must be a trend. As you can see, my trend there, it is going from 22 to 38, and then it starts to decrease. That is the trend that is also being marked. For you to score these 4 marks, that is what you need. And ensure that you have at least 2 values which are the same, which are a constant. At that point, it's going to help you to draw the correct graph as it is required. Like you have seen, I have underlined 38, 38. Now you have been asked to plot a graph of temperature against the time. So if I draw a Cartesian plane, x-axis and y-axis, so the one that comes before the word against is always at the y-axis. Is always at the y-axis. The one that comes before the word against, that is temperature. Now temperature is going to be at the y-axis. And then the one comes after the word against is going to be at the x-axis. So time is in x-axis and the time is in minutes. So hiyo ndio kitu unafaa kuelewa vizuri. That's what you want to understand. For example, if you are given distance against time, it means now distance is going to be on the y-axis and the time at the x-axis. Please remember that. So who's confused? I don't want you to confuse that exactly. Like this. Here we can have 0 for the time, a half, 1, 1.5. So you write the time in minutes. Then here you write the temperature. Temperature in degrees Celsius. Temperature in degrees Celsius. So time we have 1.5, we have 2, 2.5, 3, 3.5, 4, 4.5, and then 5. Temperature, our highest temperatures, you can see the list, we are going to start from 22. So we can even start at 20. This is 20. And then now you choose your scale. You can say 20 equal 25. You can choose your scale. Kama hii ni 20, tunaweza weka 25 hapa. 20, 30 here. So that we can cover the larger space of the graph. So here we will, that is 35 here. And then here is 40, like that. Next thing now is to put the points. The first point we have is 22. So where is 22? Inamaanisha hapa scale yangu kama hapa ni 20 na niko na 10, inamaanisha the two small squares 1 2 here, hiyo ni 21. 1 2 22, 1 2 24, 1 2 hivyo like that, 24 24 23 24 25. So ni tuwili ndio ina scale inamaenda hivyo. So if I want now 22, I will say it is 21. So 22 is here. That is my 22. 26, when it is half an hour, it is 26.5. So half an hour, 26, this is 25. 26.5 is here. 26.5 there. Then next is 6. $35, 36, and then 35. 35. So from there now, you see these things can appear as if it is you are going to draw a curve. Here, we do not have any curve. In energy changes, we could not have a curve. How do you know that this is energy changes? When you look at the questions, you come here. This is what will guide you. Assume the specific capacity. This is what tells you that you are dealing with energy changes, so we will not have any curve. So what you do now, you take a line of best fit. So you start from the original. This is 2. Unaweka rula, unaona zenye zinaingia mingi. So unaweka hapa, unachora ile straight line yenye inachukua line mingi. Ukiangalia ile ya mwisho hii, so you draw this one, yes, like this. Then inachukua line mingi. Halafu unachukua straight line again, this way. Now this line inaishia hapa na inaishia hapa. What you do, you extrapolate. So you extend with the dotted line, you extend with dotted line. Where the two lines now meet here, that one here we have what we call the maximum temperature. And that is the final temperature. So you read across, you come across here, you read the temperature here, and that is our final temperature. Now that helps us to draw to get the change in temperature. So from here, you can now read the temperature. The temperature here is 38.5. The final temperature is 38.5. So 38.5 minus our initial, which was 22.0. This gives us 16.5 degrees Celsius. Now, since the maximum is positive, then it means that the reaction is exothermic. That one should be in your mind, exothermic. The reaction is exothermic. Calculate the heat change for the reaction. Heat change is equal to mass of the solution times specific heat capacity times temperature change change in temperature. So our solution was 20 grams because the density is 1, so it means 1 gram is equal to 1 centimeters cube. 20 centimeters cube will be 20 grams. So this is 20 grams divided by 1,000 to change it to kilograms times specific heat capacity 4.2 times temperature change 16.5. Right, so this one will give us 1.386 kilojoules. The next question you will be asked is to calculate, although it is not here. So let me give the next question which you will be asked there is calculate the molar heat of reaction that that was not in this question. Calculate the molar heat of reaction between solution B and solid A, molar. Now we have already established here, we know that we used the molarity for solution B was 2 molar of solution B, HCl. But we have, so 2 is the number of moles in 1,000 centimeters cube. We will find out 20 centimeters cube is the one tumetumia, itakuwa na moles ngapi? 20 times 2 divided by 1,000 itakuwa 0.04 moles. So hizi ndio moles zenye zimereact. That is the number of moles which has reacted. Now the next thing we want to find out is if 0.04 moles was able to produce 1.386 kilojoules, 1 mole, because molar means 1 mole, will be what? It is 1 times 1.386 divided by 0.04, and that one will give you 34.65 kilojoules per mole. Because the reaction was exothermic, you remember to indicate that it is negative, and that is all you need to calculate. Rinse and depurate with sodium hydroxide solution D. Transfer all the contents used in procedure A into this photometric flask. Add distilled water up to the mark. Label the solution C. Using a pipette and a pipette filler, place 25 centimeters cube of solution C in the conical flask. Add to this phenolphthalein dropsize and then fill the table. I will use 22.4, 22.3, 22.3. Our initial is 0.0, 0.0, 0.0, and now when you subtract arithmetic, it is 22.3, 22.3. Now what is happening here is that you are bringing the solution. Remember, in the beaker tulikuwa na 20 centimeters cube of HCl solution B. Imereact na solid A imebaki. So this one it was in excess. Ilikuwa in excess. Now we have tumeleta hii tumeweka ndani ya volumetric flask 250, tumeongeza, tumedilute. So nataka ujue kwamba hii volume tumetengeneza 250, tumeita solution C. The number of moles in solution C will be equal to the number of moles in B that remained. So calculate the average of solution C used. Solution C, no, solution D. This one is a mistake, solution D. So volume of solution D used. That is now 22.4 plus 22.3 plus 22.3 divided by 3. The average should be in 4 significant figures, centimeters cube. Hii ilikuwa 222.3333, you truncate to 2 decimal places. 2 decimal places. Una truncate, si tuna round off. Calculate the number of moles of sodium hydroxide used. So when you go back, you need to remember what sodium hydroxide was 0.1 capital M. Capital M stands for molarity. Molarity is equal to the number of moles in 1,000 centimeters cube. So it means this is the number of moles in 1 liter. So that's the information we have, very important to remember. So we are aware that now 0.1 is the number of moles in 1,000 centimeters cube. What about the volume that we have used of solution D, which is 22.33 centimeters cube, will give us how many moles? So hiyo itakuwa ni 22.33 times 0.1, you divide by 1,000, na hiyo inatupea 0.00233 moles. This is of solution of hydrochloric acid, 25 of solution C. Remember, solution D has reacted with C, and the C is HCl. So it is sodium hydroxide plus HCl. Remember this excess, it was excess HCl which has been diluted, which is going to give us sodium chloride plus water. If that is the case, then you can see the ratio is 1 to 1 everywhere. So mole ratio, the equation is balanced. Mole ratio is 1 to 1, meaning that number of moles of sodium hydroxide used will be equal to the number of moles in 25 solution C. So moles of HCl solution C in 25 centimeters cube will be equal to this one, 0.00233 moles, because they are equal, because of the ratio, mole ratio. Because of the mole ratio, they are going to be equal. Calculate the number of moles of hydrochloric acid solution C into 50. That is very simple, because now we have 25 centimeters cube of C contains 0.002233 moles. We will simply ask 250 centimeters cube of C will contain what? This 250 times 0.002233 divided by 25. That one will give us 0.02233 moles. This is the number of moles in 250. Calculate the number of moles of hydrochloric acid in solution B. Solution B, you go back to what you are provided with. Look at what you are provided with. You are provided with solution B 2 molar. 2 molar means nimekuambia capital M stands for molarity. So it means 2 capital M. This is molarity. Molarity is a number in 1,000 centimeters cube. So this is 2 moles are in 1,000. So we are going to find out tumetumia ngapi. Tumetumia 20. Itakuwa na how many moles? So we ask here, two moles of B are in 1,000 centimeters cube. 20 centimeters cube will contain what? Because solution B tulichukua 20, to be measured 20 centimeters only. 20 times 2 over 1,000. That will give us 0.04 moles. That is the number of moles of solution B in 20 centimeters cube. The number of moles of hydrochloric acid that reacted with solid A. Very good. Now, what you need to know is that first, let us get the number of moles of excess HCl that remained, the one that we diluted. Now we have the number of moles of HCl solution C in 250 centimeters cube will be equal to 20 centimeters moles, will be equal to moles, will be equal to moles in 20 centimeters cube solution B that remained after reacting with solid A. So number of moles of HCl in solution C in 250 will be equal to the number of moles in 20 solution B that remained after reacting with A. We know the number of moles of solution in this, so we know hiyo ndio tushapata hapa. Tushapata in 250. So this is the number of moles in 250 solution C. So this moles is equal to 20 centimeters cube solution B that remained. This number of moles is the same because molarity number of moles does not change. It is the concentration that changes after diluting. Therefore, 0.02233 moles, which are in 250 centimeters cube solution C, will be equal to moles in 20 centimeters cube solution B that remained after reaction, But we know that original solution B 20 centimeters cube, original solution B ilikuwa na 0.04. Ndio hii tumepata hapa. Sawa? And this one is what remained. This is what remained. So which is the number of moles that reacted with A? So moles that reacted with A, moles that reacted with solid A will be equal to 0.04 minus 0.0 that remained, the one that remained, 2233, and that will be 0.01767 moles. So this is the number of moles that reacted with solid A. So that is the understanding you need to have. So this was Maseno mock for July, August. Next one, I'm going to do paper 2 for Maseno.